Hello, this is Susan Poss again. I'm an instructor at Spartanburg Community College. This is still in Chapter 7, and I've designated this 7.1.2. It's the second video in Chapter 7. This is looking at reducing these rational expressions. Remember, rational, the root word is ratio, which means we're talking about something to do with fractions. And the way we're going to reduce these fractions is to factor both the numerator and denominator. And I'll just abbreviate that N and D, and then we're going to cancel out any common factors. And factor is an important word there because it means the things that we are canceling out have to be connected by multiplication. That's what a factor means. All right, so looking at this first example, I notice in the numerator a common factor of 2. And I'm noticing in the denominator also a common factor, but this time it's a 3. So I'm first of all using my greatest common factor technique. And you can see as soon as I do that I end up, again, notice these are factors. They are connected with times. Notice that I end up with a matching x minus 5 factor, which I'm going to cancel out. And now I'm going to end up with the simplified version, which is 2 over 3. So these pieces that did not get canceled out go back into my answer. Notice the restrictions have been listed here, and you always go back to the original denominator. So if we were quickly going to look for restrictions on the variable, we would take this equation, set it equal to 0, and solve it, and we would see that the restriction is x cannot be 5, because I think you can see if you run back in here and substitute in a 5 right there, you're going to have 15 minus 15 in that denominator, which is an undefined expression. So there's our first reducing example. Here's another reducing example. I wanted to do this one because it's got the difference of 2 cubes in it in the numerator, and sometimes that's a hard factoring technique to remember. So I'm going to begin by taking the cube root of x cubed and the cube root of 64 and keep the same connecting sign. This is a formula that you would need to memorize. Then to get into the trinomial expression, you square the first term from here. On the very end, you're going to square the last term from here. And for the middle term, you multiply these two together. Whoops, I'm off the screen. It's not going to work. So it's negative 4x. I'll just have to say it. And you reverse the sign on that middle term. So that's the way that difference of cubes factors. If you've forgotten that, you can go back and review a little bit in Chapter 6. In the denominator, I see the difference of squares. And I hope you remember that factors x plus 4 and x minus 4. So again, I've got these all factored now. Notice that this is connected here with a times, and this is connected with times. So I can do my legitimate cancellation here of the x minus 4. And then the pieces that are left, I will just put those into my answer. So it looks like in the numerator I'm going to have this trinomial, and in the denominator I'm going to have the remaining x plus 4. So again, looking at the restrictions, notice that there are 2 restrictions down here listed, negative 4 and positive 4. And of course, that's where you need to go always back to the original denominator. The original denominator, set equal to 0. You can see that's a second degree denominator, so I'm expecting 2 solutions at most. And the first factor set equal to 0, the second factor set equal to 0, and that's where we get those 2 restrictions, positive 4 and negative 4. All right, this is the last one I want to do for you, and it's an important one. You'll notice then in this fraction, the numerator and the denominator kind of look alike. One is in a different order from the other, and what I really want to call your attention to is that the signs are opposite. This is a positive y in the numerator, negative y in the denominator, and if you look here, you see a negative 10 in the numerator and a positive 10 in the denominator. So something unique happens when you notice that particular pattern. I'm going to work you through this, and then we're going to talk about just remembering the shortcut. On the bottom, if I factor out a common -1, what that does is it reverses these two signs, and I hope you still see this is still a positive 10 if I multiply those back together. This is still a negative y if I multiply those back together. So I'm not changing the value, I'm just changing the way it looks. And now that I've pulled out that -1 in the bottom, I'm going to convince you that I could then turn this around to a positive y minus 10 down there, just reversing the order of these two. Notice how I kept the positive with the y, kept the negative with the 10. Now, I'm going to do my cancellation here. Notice I'm taking the entire numerator, y minus 10, with the entire denominator, and that's legitimate because that's connected down there with a times operation. So when I get through with all this, I actually end up with positive 1 over negative 1, which of course is equal to -1. So what I want you to remember from this is that anytime you have an expression like that, let me give you a couple more to think about. Let's say you had an x minus 7 in the numerator and a 7 minus x in the denominator. You would know that that's going to turn out to equal -1 without having to do a lot of work. Or let's say that you had a k minus 13 in the numerator and a 13 minus k in the denominator. You would know also that that was going to turn out to equal -1. There's the little summary rule right there. So that's a good place to stop the little part about reducing fractions.